Welcome to the Artificial Intelligence Podcast with your host, Dr. Tony Huang. Today, I'm with a special guest. Kesh, can you introduce yourself?
Hi, Tony. This is Kesavadas. I'm the VP for Research and Economic Development at the University of Albany, a part of State University of New York.
So, Kesh, how did you start your journey? Like, how did you become the VP? I think a lot of people would like to know, like, your background. Like, what was your journey like?
Thanks, Tony. I'm an engineering faculty. I'm a PhD in industrial engineering from Penn State, where my work was mostly focused on robotics, AI, and virtual reality. Very early proponent of virtual reality. And I started my journey at Iowa State working on really cutting edge VR center there in mid 90s. And then I moved to University at Buffalo, where I was a faculty in mechanical and aerospace engineering, working in the space of automation and robotics. I also started a virtual reality lab there, which was one of the very first in the world. I'm talking about 1996. I was teaching a course in virtual reality, which is probably much ahead of its time. Use of virtual reality in all kinds of things in design, in manufacturing. And then slowly I moved towards medicine. By end of 1990s, I realized there's a great opportunity for using VR and artificial intelligence in medicine and healthcare, broadly speaking. And I spent many years building training simulators for doctors and eventually ending up doing a really an innovative, I would say for that time, a training system for a medical robot that had just come into the market called the Da Vinci. Now, Da Vinci robot is everywhere in the world, but it was very early on in the mid 2000s when I teamed up with a doctor at Russell Park in Buffalo. His name is Dr. Guru, and we actually developed the very first training simulator, a standalone system for robotic surgery. It was a great experience. And in the process, I also spent a lot of time doing translation, converting patents, starting a startup company called Simulator Surgicals, raising money for the business, while at the same time also running a very good lab with 10, 15 graduate and PhDs and postdocs. Around that time, Illinois in Urbana-Champaign came knocking because they had a vision of starting a new center in healthcare. And I went on to be the founding director of a center in Illinois in 2014. And we were fortunate to get a really nice endowment of money from a hospital and a foundation, and that called a jump endowment. We started a program called Arches, which very soon grew into over $100 million endowment, where the goal was to bring engineers and doctors to work together. And we were making grants. And especially during the COVID time, it came very handy because our center played a very crucial role in helping develop some new techniques for COVID, for looking at how engineering can be helped in various parts of healthcare system, manage COVID and things like that. I built a really experience, very broad. And one side engineering, other side working with doctors, healthcare, and also in very large, grand, visionary ideas and things like that really got me interested in doing the administration part. And so in the end of COVID, Albany at SUNY, and it turns out I was at University of Buffalo before, which is also part of SUNY, that is the State University of New York. And so when I got an opportunity at applying for a vice president's job, looking at the entire campus-wide research, I thought that it fits my profile and my vision of looking at research more broadly than just engineering and science. And so I applied for the job. And in January of 2022, I joined University of Albany as the VPR. And a little bit of a change that happened from the previous position was that they added a new job description. They added economic development as a part of the job. So I'm the VPR for just Vice President for Research and Economic Development. So my job today is to oversee the entire research infrastructure for the university, look at where the technology is moving, the research is moving, create an environment for people to work together across the campus to write large grants. At the same time, look at how the research makes an impact on the society and healthcare and things like that.
Oh, very cool. And so, over the course of the last decades of working, what were some trends that you saw that really stuck out to you?
I would say that maybe I'll break that into two or three areas. One I've seen is that the multidisciplinary research has become much more prevalent than it was when I started my career as a junior faculty, right? When in the 90s, mostly faculty members wrote individual grants. That started changing when the National Science Foundation started encouraging larger grants where more than one faculty or more than one institution would work together. So that has been a big impact where the wisdom was that to tackle a big challenging problem, you had to look at it from multiple angles, right? Look at what is the social impact. You at the same time look at the science, the engineering, the data, and things like that. And so that has been the prevalent model that has led SF and NIH to create institutes like NSF has an NSF Institute on AI, for example. So all of these changes happened because of the fact that people have started looking at research as a much more complicated thing. The second thing I would say is that a big change in research I've seen over the last 20 years is the impact of data-driven approaches in every field. Today, AI has come to become very mature, but they did not happen overnight. This impact of looking at data, looking at machine learning, and as opposed to looking at a more analytic solution has already been happening in drug discoveries and all of these areas is all been culminating towards this heavy AI-driven approach that we see today.
Yeah. So speaking of AI in industry right now, like the biggest, hottest thing is AI. And more specifically, it's about generative AI. That's what I'm seeing. Like every company wants to slap generative AI on basically everything. Like even companies that aren't AI focused, having AI as its core, is implementing some sort of AI into their operations production. Where do you see like generative AI going in like the higher education world? Are you guys like preparing students for the upcoming Gen AI craze? And if so, what's the plan? What do you have in store?
So let me start by saying that University of Albany has been at the cutting edge of implementing or integrating AI. About 2 years back, we started a program in our campus called AI Plus. The idea is that AI plus everything else, AI plus education, AI plus research, AI plus bioinformatics, could be anything. That program itself is unique in the sense that it brought every part of the campus to integrate AI, not just computer science or engineering. It had an academic component, which means that every student who came to Albany, whether they're doing history or doing music, they were introduced to AI from the very first year. And as they progress through the 4-year program, they do more and more advanced courses. So found knowledge of AI is being integrated into education. So these students, when they graduate, they know more about AI, the risks in AI, the ethics of AI, and all of those things, in addition to how AI impacts their world, better than a layman would by reading New York Times or some magazine, right? Because they're getting foundational knowledge. And at the same time, we also invested significantly through a big $75 million grant we got from New York State to set up a computer that will allow our faculty members to do large AI models like what industry would do, right? Like Amazon's and others, because they have this farm of GPUs. And OpenAI was working with Microsoft to do all this ChatGPT 4 and 5. No universities have that kind of access. So how do academicians and people do large model? That was the philosophy. So when we got the 75 million to build the computing facility here, we are already one of the only 2 or 3 universities in America to have that level of GPU farm for us, our faculty, students, and our collaborators, including outside organization, government, nonprofit, and others who work with us to do that. So when this generative AI craze started a few months back, we are already built the infrastructure and the education components and the different areas of research, whether public health, that was ready to jump into this idea of that generative AI is everything, right? So we are now working in a number of research projects on campus that touches generative AI in one way or the other. It may be drug discovery. It may be looking at semiconductor design of semiconductors, where University of Albany, you probably know, or College of Nanosciences and Albany Nanotech. We have one of the biggest semiconductor research facilities in the country. So again, looking at the AI. At the same time, students are also learning how should you be using ChatGPT? What is it? So faculty members are, in my opinion, after the initial oh my God, everything is going to be copied. People realize that generative AI is here to stay. It's word processing from typewriter to word processing is here to stay. The spell check is here to stay, right? You can't say don't use spell check, right? You have to use dictionary. No, it doesn't work that way. So I would say faculty members in the campus very early on realized that. And so every faculty, based on their own experience, have their own policies on how you can use ChatGPT. When do you have to declare that you use a ChatGPT? How do you confirm that the ChatGPT answer is true and it's not some fake data is churning out? And at the same time, also improve the make life easier so that your research you focus more on the real content than on some of the things that ChatGPT can help. So I would say that as an academic institution, we are really doing work in seeing how ChatGPT would or generative AI would fit into the education research curriculum here.
Yeah, gotcha. Yeah, it's really refreshing to see a top-down push for using innovative technologies and like next generation tech, like Gen AI, being pushed on the students so that they can be better prepared when they enter the workforce. I did remember like when I went to U Albany, I got my doctorate there, and I did remember having a really good experience with my two co-advisors, Alan Chen and Ken Halverson. They were very receptive of using innovative tech in order to push it. And it's now we're seeing that being pushed across the all campus wide as well as
Yeah.
through the region. So this is really great news to see like this type of innovative thought leadership. I'm interested in what do you think about using Gen AI as a tool to help accelerate research? Like, how are you guys using that in that sense? I've talked to a lot of industry leaders, for instance, like in the biotech space, where they're because Gen AI is like a sequence predictor, can predict the next sequence in this chain. The easiest thought process right now of using Gen AI is using words, like predicting the next word in a sentence. But I've seen a lot of biotech companies using Gen AI to predict like the next codon in the sequence, right? So you have a start and stop codon, and you can actually predict the next sequence in that string. So like, how are you guys using like Gen AI, like as broad
Yeah.
strokes? Like, how are you using Gen AI in terms of like research? Do you have any like cool use cases that you can disclose?
Gen AI, yeah, I can say that almost every group who's doing research is thinking of how Gen AI is going to be either help them or make them think of, you mentioned biotech, you mentioned drug discovery, RNA. Obviously, those areas are already adopting it. But in the campus, let me not talk about individuals, but let me talk broadly. There are the several groups that's working on Gen AI type technologies. And maybe I'll focus on one or two that I've been personally involved in: mental health and AI. Okay. So we launched a center for AI in mental health in 6 months back in collaboration with the downstate SUNY campus and a United Nations affiliated organization called Health Innovation Exchange. A Health Innovation Exchange works across the world in technology and healthcare and launching things like that. So the goal of a center is to see how AI can be used in workforce training. At the same time, also get insights into people's thought processes, right? At the same time, help students navigate challenging situations. And finally, looking at how we can help the state in the space of mental health. Now, one really interesting project that we have all been working together is to look at how generative AI can help in predicting the, let's not say predicting, but triaging. In mental health is an area where there are not enough providers who can help people, right? So a statistic shows that an average person waits 6 to 8 years before they get some counseling or help in mental health, right? And one of the reasons is that the people first don't know where to approach, and second time people don't realize that there is some underlying issue going on with people, and it's only when people become very serious or if there is a suicide attempt or is when people eventually go and look for help. And then sometimes even they want to help, there is not enough providers. So we are trying to build a foundational model for AI. The foundation model is really okay. So now The large models that's available today, right, like ChatGPT type models, are very generic in nature. So if you look at the future of where AI is going, is developing models, which I would call like micro models, that uses the foundation of large model, but is fine-tuned to be much more accurate in your own domain, right? That's pretty much one of the directions that almost every group in the campus is looking at. If I have a large model, how can I help look at cancer or this or that? In the same fashion, we are thinking of this as a mental health model, foundation model that is very accurate, that somebody could type in something and would give a diagnostics on a patient, which people would trust. So right now, if you ask me, will anybody use Chat GPT in the mental health area? No, because it's too generic to look at a patient. But if you have the foundation model that takes a scientific knowledge, maybe also uses data from patients over the years, you can have a model very good. So here's an example of a generative AI type approach or a large language model, which is much more reliable, that people can use to triaging, but it also could be used for training purposes, right? If I'm a novice counselor, I could be working with the generative AI as though that I'm talking to a real patient, and you'll start seeing scenarios which is very similar to what they will see in real world without having the real patient or an actor trying to do. There are hundreds of applications. So I would stop at that, because this is something that I've been personally advocating and working on.
Yeah, that's such an interesting topic of using LMs for mental health. There was a company that it specialized in mental health through through a chat, right? So you had these therapists that were on the chat lines chatting with patients, and that company swapped out the humans with a chat bot. And the study showed that the recipients were actually favored the responses of the chat bot over the human, but there was a but the moment they found out that it was an actual chatbot, like the returns
Yeah.
diminished. And so there was like a bias towards like the LM responses, which I thought was very interesting. So
Yeah.
like in a blind test, the
They
LM
believe
did
more
outperform
better.
humans for mental health in that study. And I find that topic very like intriguing. I think that's like the future of mental health, is using chatbots, just from these like small studies that have popped up. And I've also noticed what you've noticed, what you said, which is these micro LLMs. They're popping up everywhere right now. Last year at the Databricks AI Summit, one of the biggest topics was small language models, which basically you take a large monolithic LLM and then you distill it into a small language model that's lightweight, and you can fine tune that to industry specific like use case. And now we're seeing even smaller and smaller language models, which are now called micro LLMs or micro LMs, and those are proliferating throughout industry. So I'm very excited to see these very niche industry specific language models pop up. To start off with, I think mental health is a great starting point, especially in the like COVID and post-COVID era, where I was talking to some therapists and they said that over half of Americans are on antidepressants. And you can actually test it in the waters. If you go into the sewage water, you can actually test
Yeah, the
the
difference.
presence of antidepressants, which I think is astounding. So there's a huge need for mental health. We're seeing that across the board, right? We see studies about the antidepressants usage. There's also gun violence that's occurring because of mental health issues. So I think a big push through like legislation as well as products being built for that is the way to go. Are there any other use cases that you can think off the top of your head that stand out to you in terms of what you guys have been working on?
Quite a few. There are people working on models in weather and climate prediction. That's a big area in our campus, as you probably know. The ASRC, or Atmospheric Science and Research Center, is one of the cutting edge centers. We have been working on looking at AI on prediction of the ice on the thruway, for example. And we also been working on things like using AI for predicting snow, a change of rain to ice, snow. And in fact, the State Weather Resiliency Center, called SWRCC, helps the state of New York in anytime there is a big weather event in the country. So it is located in our campus. We also collect data from across the state called Mesonet, that is 126 centers across the state, which gets real-time data every 3 minutes. So we are using those kind of data to do big, large models to together. The goal eventually is can we simply use the model alone to predict very accurately the in the direction which the weather is going, but then also use these kind of models to help people, companies who are doing like wind farm in the coast, right? How can they accurately model so that they know where to put the wind farm or how the wind farm's efficiency are? Those are things that is very impacting the future of energy and things like that. So that is another big area that we are working on, helping a NOAA type organization. The second area that we are working on generative AI is on decision making in disaster relief and things like that. There is a big group on campus is working on interfacing with data models and making tools that if there is a natural disaster, how does that's when the communication might break down or the roads might go down. So how can we make decision and things like that? And generative AI kind of tools, putting all the data of like last 100 major disasters, modeling from that to learn from that, so people can predict the direction which what will happen in the next 12 hours or 8 hours. That might make the planners and others really focus on the things that's needed and not be completely be taken by surprise.
Yeah,
Or when
yeah,
fire.
that's really cool because the nor'easter usually hits every year. Having that preparedness is key. I remember when I used to live out there, the electricity would go out every time the nor'easter would hit. So
Yeah, absolutely. And you don't know the road condition and all of these things can happen. Ice on the trees, breaking down the trees, all of this can, and also flooding too. If you look at it in the last 25, 30 years, there's a Sandy that happened, sub-basement buildings in Manhattan getting flooded in one single rain. So there's a lot of unpredictable things that is happening with oceans rising and the temperature going up that AI is going to play a significant role. And I think that at U Albany, with all the computing help that I mentioned earlier, our goal is to eventually try to help the entire Northeast area, not just state of New York.
gotcha.
In Puerto
Yeah,
Rico too. We work very closely in Puerto Rico, and we also work. Our teams are also working on forest fires.
yeah, yeah. That's really interesting. I know Australia is using AI for forest fire prediction and mitigation. Yeah, and then I think Cali is also looking into that because like the forest fires in California, they just rage on and on.
Yeah, I believe that we have faculty members who are being funded to look at some of the forests in other states like California too.
Yeah, very cool. And so I'm interested in what's on the horizon for you guys. Tell me some insider knowledge. What do you guys have planned? Any like big initiatives, big projects happening? Anything that's close to being finished that you want to disclose?
I say one of the exciting things that we are going to announce very soon. So we just launched a center in collaboration with IBM called Center for Emerging AI. That center is looking at moonshot projects in AI. Okay, so one thing I would, if you want me to share, is that next month we are going to be calling for grants internally and providing them also with very advanced computing help that maybe another 2 weeks we'll announce, but maybe a little too early to announce. It's a new AI system that is going to come onto campus, which will be the first of its kind in the world, that we will be the first to have it outside an R&D facility. And once that comes in, we will be giving grants for faculty members to use that facility to do some very large modeling, whether it's weather and things like that.
What's special about that facility that sets it
So
apart?
the facility, it's a system that is being developed and is developed by IBM. And in our center for IBM has a center in Albany Nanotech called the AI Hardware Center. So some of the cutting edge work coming from that. I can't add more to that until the actual announcement happens. But I think very broadly, we are looking at computing where it's more energy efficient.
Got
That's probably the limit to what I can say.
yeah, 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 no problem.
As you know, energy is one of the biggest problem in computing, right? Because it's a power hog, right? All these farms can like, eh,
You know the problem. So the big problem with the computing resources for Gen AI
yeah,
is because of the fact that it uses transformers. So
yeah,
transformers require, in terms of memory usage on RAM, it's a quadratic problem. It scales quadratically, which requires a ton of VRAM,
absolutely. Yeah.
and that's why there's so much usage. There's some cutting edge frameworks out there right now that's moving away from transformers, and it's more of a linear. It scales linearly
Uh,
in terms of resource requirement. So once that breaks ground, I think all of our energy problems in terms of generative AI consumption would go away. Right now, it's too expensive.
And these problems are scaling very fast, right? And there's also a lot of, if you look at how the generative AI whole field has grown, there's a lot of random training happening, right? It's not efficient in many sense, right? Sometimes all these billion parameter models are done simply because because all these models are done without thinking, right? In the sense that, okay, let's put everything inside. So there's a lot of opportunity for making those approaches more efficient. So you get the same level of models which is as good with 1/10 the amount of parameters, right? And that also is a way that some of the GPU designs are looking at, right? It's also, can you make GPUs that are less precise, but does the same amount of learning, right? And if you can do that, then the energy consumption can go down, but the end result for a broad set of problems is still good enough, right? So there are a lot of approaches that people are trying to do. And so I think that some of the work that's going on in our campus and what we'll be announcing will be actually focusing on some elements of making large language models or generative AI more efficient.
Yeah, I know that in industry there is a big push in terms of the open source community to quantize these models, moving away from GPU like enabled LLMs. They're actually trying to move into like the CPU powered LLMs through the quantization, and that's just really it's very slow and tedious right now. And I think it all goes back to the transformer framework. That's the big problem. So we kind of have to move away from these, and new frameworks will come up, and once they come up, then all the efficiencies will increase, and then we'll be able
Yeah.
to scale hardware wise. And so I think that'll be in the future. And speaking of the future, what's your prediction of the hot new stuff that's going to pop up? Do you think that Gen AI is just like a craze that will like subside in a couple of months, years, or do you think that it's here to
No.
stay? Do you think that there's something else that's on the horizon? Because like in industry, before Gen AI took off, the big hot stuff was actually edge computing. Everybody wanted to do edge computing, putting computers on the edge that had limited internet connection, and had models trained on it locally, running it locally. That was like the big hot stuff. But then when Gen AI took over, edge computing went off the cliff and no one cared about it anymore. What's your prediction on the next hot stuff that's going to happen?
I think my guess is as good as anybody's guess, but my thoughts are that you're going to see a significant jump in the design of the next generation of GPU and chips. Okay. That field, you can say Moore's law is hitting and things like that, but at least some of the meetings that I've been going to, some of the AI hardware meeting, some of the multi-layer 3D type chips that's coming in the market, and even packaging is changing so much that the whole field is moving away, right? $1.5 billion NVIDIA is there, but 2 years from now, what is it going to be? I think that you will see some significant new technologies coming out there in the hardware. If that happens, then the whole way how generative AIs are being trained or how AI is being implemented may change, right? You might find more embedded systems with AI built into it much more stronger, so that you can have systems in your hand and in your watch and things like that, which is something that today you have to go to cloud to do it, right? So those kind of miniaturization in system, and the systems that can actually be powered using your batteries or things like that will completely change systems. So one area, or maybe I can say a couple of areas, I think that will make a huge impact. One is in the medical device area. You might see the next generation medical devices being exceptionally intelligent, right? You might have a heart monitor system. Today, it can do some basic stuff, but in the hospital, still doctors still look at the data and make prediction. But you could have systems which are much more, can do a lot more than human beings can even look at that. You can have robots in the future. Robotic surgery is a big thing, but if you really look at the robotic surgery field, it is pretty crude today. It is still a significantly human controlled robot. So surgeon sits and controls by hand, the robot mimics telerobotically. We could see robotic systems that are self-aware, understand, take this data from image and things like that. And the other area is probably in the consumer domain. You might see consumer devices going to be much more intelligent, that connects to your mobile systems, to your automated driven cars, or whatever you're driving. So I think that this chat GPT world today largely resides in modeling or design, or you writing your CV, or generating, is going to move into much more hardware driven world where this will be integrated so naturally that the whole next phase of, you see, industrial 4.0 IoT, that is just a beginning. But this would be real IoT, which is built in, you don't need the cloud and things like that. I think it's already moving towards that direction. Maybe there are drugs that is going to be completely designed with the press of a button. You go to a doctor's office and they look at it and you press few button and you have a drug that's designed. It's not going to cost you $1.5 million for that drug, but it is going to cost you just like buying a drug off the shelf. It's simply because these things can be tuned and this can create drug just for you. So everything will happen in 20, 25 years or earlier.
I've seen a lot of movement in terms of like Microsoft teaming up with research groups to develop like brand new chemicals that haven't existed yet. So
Yeah.
the chemical engineering part is just, it's astounding how fast they're able to do it. Like before it took years and now they're able to do it in a matter of hours using like these AI powered
Yeah, I mean,
solutions.
even if you look at mRNA, right? If you look at Moderna, I can talk about Moderna specifically. The mRNA solution they've eventually used for the COVID was one, they came up with four solutions out of billions of possibility. But those four was done really using AI. And all four of them worked. And one of them they went to the market with. And I was in a meeting, and sorry, we had a speaker who was the chief medical officer in Moderna earlier. And she was saying how one of her graduate students actually was working on it. And he came up with the formulation of mRNA in a day or two or a week, I don't remember how. That's the one that went into the market eventually. And they are now doing the same thing with all kinds of future vaccinations and mRNA for cancer and things like that. They're all possible only because of AI, right? Because nobody can test a billion samples on human beings. But how do you find that three or four, which may be possible cases, and then you can start doing drug trials and looking at the efficacy, right? So it's completely revolutionizing, right? This large molecule, are going, and now you're finding completely new generation of molecules that's revolutionizing. Most of the drugs we see in the market will be out. Nobody will be using it in another 5 years because you have a completely new generation of drugs that's coming on, mainly because AI existed, right? Not couldn't have been existed otherwise.
That's so fascinating. So Kesh, if like our viewers wanted to get in touch with you to learn more, like how would they do that?
I'm on LinkedIn. That's a good way to go and check out on that. Obviously, my university email ID is public knowledge. Is Kesavadas at albany.edu. People can always send me email. Yep.
And then last question for the viewers that want to get into this space, what's a good starting point? What would you recommend them? Where would you recommend them going? Are there any tips and tricks that you can tell them that you've learned in the past that they could use?
I would say that if you're a high school student or thinking of a career, it's very likely that any undergraduate program you go in the next couple of years, you will be seeing AI just like you would be seeing history and liberal arts, right? At least in Albany, you will. I would say come to Albany, you will get a lot more than any other university. So I'll pitch for Albany. But also the fact is that having taught a lot of educators across the country, everybody's thinking of what we are doing, something similar to create a program that introduces AI. So most likely you will be learning AI in your curriculum. But I would, if you're not already thinking of it, I would also suggest that think of a program where you can get a foundational idea of AI because it is there anyway. If you might be thinking that I'm going to work in insurance industry, selling car insurance, but guess what? AI is already there, right? Deciding who should get an insurance or not. It's there everywhere. So you may be becoming a lawyer, or you might be choosing to work in a patent law or whatever. You have to understand the foundation of AI. And so I think I would recommend that look at programs that you can get introduction to in the near future, but in 4 or 5 years, it will be there everywhere. All the campuses, every other university will have programs that's integrated like what we are doing here in AI Plus.
Thank you so much for being on the show. And until next time, stay curious.
Thank you, Tony. Thanks for having me in the show, and I look forward to talking to you again.